Good morning. This is very important question on Lebesgue integral. Consider these two functions and we need to check which of these functions are Lebesgue integrable. On this closed interval 0, 1, now when the function is Lebesgue integral, if the integration of fx dx is finite from 0 to 1, then we say that this function is Lebesgue integral. The integration should be finite. The function is having this value for this interval and 0 for x equal to 0. Now since 1 divided by x to the power 2 by 3, this value is tending to infinity as x tending to 0. That means this function is unbounded. Right? Let's write this. Let's define the function fxn. It is giving the value 1 divided by x to the power 2 by 3 for x greater than equal to 1 divided by n to the power, let's say 3 by 2, and less than equal to 1. For this interval we are having this value, and is giving the value n for x greater than 0 and less than 1 divided by n to the power 3 by 2, this. And it is giving the value 0 for x equal to 0. That is, for the values of x lying in this interval, the function is giving the value 1 divided by x to the power 2 by 3. Here, these 2 points are included, as this interval is closed. This is your open interval, so we are not including the points 0 and this 1 divided by n to the power 3 by 2, for which we are having the value of f of xn to be equal to n. And for x equal to 0, we are having the value of f of xn to be equal to 0. So which means we are going to integrate now f of xn dx from 0 to 1 to be equal to the integration, okay, from 0 to this point. We are having the value of fxn to be n, plus from this point to the point 1, we are having the value of fxn to be 1 divided by x to the power 2 by 3 dx. So this is equal to, integrating this integrand with respect to x, we get nx, and the limits from 0 to 1 divided by n to the power 3 by 2, plus if I take this integrand to be x to the power minus 2 by 3, so I am having the integration for this to be x to the power minus 2 by 3 plus 1 divided by minus 2 by 3 plus 1, and the limits are from 1 divided by n to the power 3 by 2 to 1. So this becomes 1 divided by 3, and here also we have 1 divided by 3, which can also be written as 3 into this. Right? And now when putting the upper limit, we are getting n into 1 divided by n to the power 3 by 2, minus, putting the lower limit we get 0, plus 3 times this to be 1, minus, putting the lower limit we get, right? So this is equal to, when n is multiplied with this, we are getting n into n to the power minus 3 by 2. So this will be equal to n to the power minus 1 by 2. So that is 1 divided by square root n, plus 3 minus 3 divided by square root n, and that will be equal to 3 minus 2 divided by square root n. And this is the integration for f of xn from 0 to 1, which is coming out to be finite. And this is for all n, right? So hence, by the definition of Lebesgue integral, of unbounded function, we have the integration of fx dx from 0 to 1 to be equal to limit n tends to infinity, the integration of this f of x n dx from 0 to 1. So this is equal to limit n tends to infinity. And what is the integration for this? It is this 3 minus 2 divided by square root n. So that will be equal to, when n is tending to infinity, we are getting this to be 3 minus 0. So that is equal to 3, which is finite. Hence, f is Lebesgue integral in closed interval 0, 1. And now let's check for this function gx. So for this, we are going to define the function gxn to be equal to, just take the value 1 by x for x greater than equal to 1 divided by n and less than equal to 1. And it gives the value n for x strictly greater than 0 and strictly less than 1 divided by n. And it is giving the value that is minimum of 9n for x equal to 0. So therefore, when taking the integration of gxn from 0 to 1, from 0 to 1 by n, we have this n value. So from 0 to 1 by n, we have n dx, plus from 1 by n to 1, we have this value, and for x equal to 0, we have minimum of this. So integrating n with respect to x, we get nx, and the limits are from 0 to 1 by n, plus integrating this, we get log of x, and the limits are from 1 by n to 1. So this is equal to, when putting the upper limit, we get n into 1 by n, minus when putting the lower limit, we get this to be 0, plus when putting the upper limit, we have log of 1, that is equal to 0, minus when putting the lower limit, we get log of 1 divided by n. So this is equal to n multiplied with this, we get 1, plus this is 0, minus this is log of 1 divided by n. I can write this further as log 1 minus log of n. So that is equal to, log 1 is again equal to 0, and we have 1 plus log of n for all n. So we have the integration of gxn from 0 to 1 to be equal to this. And again, by definition of Lebesgue integral, because 1 by x is again tending to infinity as x tends to 0. So this is the condition for the unboundedness of g. So by definition of Lebesgue integral, the integration of gx dx from 0 to 1 is equal to limit n tends to infinity, the integration of gxn dx. So that is equal to limit n tends to infinity. What is the value for this? It is 1 plus log n. And when putting n tends to infinity over here, we get, what is log of infinity? It is infinity, right? So hence, g is not Lebesgue integral. G is not Lebesgue integral. The value is not finite on closed interval 0, 1. So hence, first option is correct and last option is correct. So answer option A and D are correct for the given functions. Alright, thank you.